Hello friends, today's topic is the Buckingham pi theorem, and the Buckingham pi theorem is a topic of the fluid mechanics and the branch of the mechanical engineering. So Buckingham pi theorem is the very simple theorem. And what is the Buckingham pi theorem? The Buckingham pi theorem means that the number of independent variable as well as the dependent variable we have to separate it and find out the pi 1, pi 2, pi 3 in the terms of the given example we have to find out. Okay, so Buckingham pi theorem is a very simple theorem. So first of all, the in that example we have to ask this question: tau w equals to tau w is the function of the diameter d, density rho, dynamic viscosity mu, and that is the roughness is the considering the sign. Okay, epsilon, sorry, epsilon, that we have considering the roughness, and velocity v, so it is the velocity. Now what we can do in the next step, the step number one, there are the 6 parameter in this problem. So n equals to 6. Now number of independent variable tau or shear stress is the dependent variable, and the independent variable, this is the diameter d, density rho, dynamic viscosity, and the epsilon, that is the roughness, and v is the velocity. So these all are the independent variable, and these are the dependent variable is the shear stress. So it's just, that's why we can conclude, or we can say that the n equals to 6. Now the next step is step number 2. Just one second, we have to little bit change. Okay, just one second. So step number 2, what is the step number 2? Write the primary dimension on each parameter in MLT form. What is the MLT form? That means the MLT means mass, length, and time. This is the MLT form. Okay, now what we can do in the MLT form, we have to convert this example, or this question is converted into MLT form. So shear stress is equal to m l raised to minus 1 t raised to minus 2. So diameter is the l raised to 1, tau equals to m l raised to minus 3, dynamic viscosity mu equals to m l minus 1 t minus 1, and epsilon equal to l raised to 1, and velocity equals to l t minus 1. So we have to conclude, or we have to, step number 2, we have to convert into the dimension or primary dimension, we have convert into MLT form, like the mass, length, and time. Okay, so these are converting into step number 2. Now next we have to go to the step number 3. So first of all, step number 1 is what? The step number 1, we have to, first of all, the 6 parameter, number of parameter we have to write down up, and after that what is the independent variable and what is the dependent variable, with what we can do. Okay, so we can adjust, or we can simplify the what is the independent variable and what is the dependent variable. And step number 3, that we have to convert into the question is the MLT form, mass, length, and temperature. Okay, now step number 3, step number 2. Okay, now step number 3, what we can do, number of primary dimension. So j equals to 3. What is the number of primary dimension? So number of primary dimension, that we have to, entire example we have to constant. So pi 1, pi 2, and pi 3 value, we have to, these 3 parameter we have to repeat it. Okay, we have to same as it. Okay, so number of primary dimension j equals to 3. Now number of pi predict in the example, so k equals to n minus j. So 6 minus 3, so equals to 3. Okay, now step number 4, what we can do in a step number 4, choose the repeating parameter. So we have to conclude the choosing the repeating parameters, like a diameter, density, and velocity, so d, rho, and v. Now what we can do in a step number 5, we have to conclude them pi 1, pi 2, and pi 3 in the terms of the diameter d, density rho, and velocity v. We have to find out in that example. Okay, so now first of all, what we can do, pi 1, because why we have to judge, or why we have to call the pi 1, pi 2, and pi 3 is the only the 3 parameter, because we have to choose the repeating parameter as 3. So that's why we have to find out the value of the pi1, pi2 and pi3. Okay, is that clear? You can understand, easy to understand. So okay, now next step number 5. So pi1 equals to shear stress in bracket diameter d, density rho and velocity v. So after that, what we can do, we have to convert into MLT form. So tau w equals to m at raised to -1 t raised to -2, d equals to l raised to 1, density equals to m l minus 3 and v equals to l t raised to -1. Now what we can do, we have to apply or we have to find out the pi1 value after that, step number 5. So what we, after that, pi1 equals to tau in bracket d rho and v. Okay, diameter, density and velocity. So we have to, in that, instead of this place, we have to form, convert into, write down the MLT form. Tau equals to m l minus 1 t minus 2 l 1 m l minus 3 and t minus 1. Okay, so we have to, instead of this, we have to write down this. Okay, ml minus 1 t minus 2 l raised to 1 ml minus 3 ld. Okay, now we have assumed d raised to a, rho raised to b and v raised to c. So that we have assumed that d raised to 1, sorry, we have assumed that d raised to a, rho raised to b and v raised to c. Now what we can do, just one second. Okay, after that we will apply it to m equals to here 1 plus here b. So b equals to -1. Now t equals to -2 over here and minus c over here. So c equals to -2 and l equals to -1 over here plus a over here plus c over here minus 3b. Okay, so after that, what we can do, after that we have to apply over here -1 plus a. Okay, now b value is given to earlier -1, so we have to, instead of the b, we have to put the value of -1 and c, instead of the c, we have to put the -2 value. So after that, a equals to 0. So we have to find out the a, b and c. So a is 0, b is -1, c is -2. So pi1 equals to tau w in bracket d raised to a, rho raised to b and v raised to c. So tau w equals to d raised to 0, rho raised to -1, v raised to -2. So after that, tau w equals to d raised to 0. So that is the cancel out or 0. So rho raised to -1, v raised to -2. So pi1 in the terms of the rho and velocity as well as density, rho and v. So tau w is equal to rho into v square. Tau w upon rho into v square. Sorry, pi1 equals to tau w divided by rho into v square. Okay, now further again we have to find out the pi2. Same thing happen over pi2, same procedure follow in the pi2. Okay, and we have to find out the value of, in terms of the diameter, density and velocity. Okay, so next pi2. So pi2 equals to mu dynamic viscosity in bracket d rho and v. Instead of the mu, d, rho and v, we have to convert, or instead of that value we have to put the MLT form, ml minus 1 t minus 2 l raised to 1 ml minus 3 lt minus 1. After that we have to assume that d raised to a, instead of earlier we have to pi1 find out, they assume this simple funda, the d raised to a, rho raised to b and v raised to c. So m equals to 1 plus b over here. So b equals to -1. After that t equals to -1 minus c. So c equals to -1 and l equals to -1 plus a minus 3b plus c. So a equals to -1. So pi2 equals to d raised to -1, rho raised to -1 and v raised to -1. So over here a, b and c equals to -1, -1, -1. So these are the a, b and c. So pi2 equals to mu upon d rho v. Okay, so in the terms of the pi2 we have to find out mu equals to d rho and v. Now next we have to further, again same procedure is a pi3, we have to find out. So pi3, what we can do, pi3 we have to constant as a epsilon, so it is a roughness. So L raised to 1 in bracket L raised to 1 raised to a ml minus 3 lt. We have to convert to, instead of the epsilon d rho and v, we have to convert into mlt form. So m equals to b equals to 0, c equal to also be 0, because over here same procedure earlier we have to find out the pi 1 and pi 2, so we cannot be further again this procedure is follow. Okay, so not a follow. Now the L equals to 1 plus A minus 3B. So A equals to minus 1. Now pi 3 equals to D in bracket D raised to H. So minus 1 rho raised to 0 V raised to 0. So these are rho and V is a cancel. So D, so pi 3 equals to epsilon upon D. So final, that in that example final we have to conclude the example, and final answer is the pi 1, pi 2 and pi 3. So conclude that answer is the pi 1, pi 2 and pi 3. Tau W upon V square, mu upon rho Vd and epsilon upon D. So it is the easy to understand. I hope you are understand. And the in an external examination, semester examination, as well as the in any competitive examination, this question or this theory is the asked in the competitive examination. So I hope you are understand, and this example is too easy to understand, or you have to able to understand how to solve that type of example. Okay, so thank you very much. Keep watching my next video. Thank you.